Hello, dear students. I am Samir Velankar and I welcome all of you to this another video on control structures in C. Let us see some more examples of switch case. We were learning switch case in the previous video. Now, the question asked here is convert the following if else into switch case. The if else given over here is if P is 10, some variable P is having value 10, then execute statement A. But if P is not 10, then go to else and check the next if. The next if is asking is P equal to 12. If P is 12, then execute statement B. Otherwise, the last else execute statement C. So C will execute if P is anything other than 10 or 12. Simple. So that's the nested if given. And we are asked to write this nested if in the form of switch. So you will write switch bracket, and remember in the bracket you write the variable which you are comparing. Here the variable which you are comparing or the expression which you are comparing is P. So switch expression, the expression here is P. Switch always is followed by brace and the reserved word case. Remember case means equal to equal to. So you are comparing P with some value. Now which value you want to compare with? It is 10, isn't it? Now I have purposely taken this example to begin this video is that many students are under an impression that in the switch, the first case has to be case 1. Very silly, actually. Very few students will feel that. I don't know. But many students feel that in the switch, the very first case has to be case 1. No, 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 no. It's not like that. You have to ask that P is compared with which value. Now, the value with which we want to compare P, look at the original if statement, is if P is equal to 10. So, hence, the first case will be case 10. What are we asking? We are asking if P is 10, then execute A. And don't forget break, which will pull the control out of switch. If case 10 is true, it will run A and pull the control out of switch. But what if P is not 10? So you will write, is it 12? That's what our original if is all about. Then run B and then break. And what if it is neither 10 nor 12? Then you have default. This default exactly coincides with the last else, isn't it? Then run C, and you know, anyway, default is the last statement, so no need of giving break. Anyway, control will come out of the switch, so you give close brace. Yes, I hope you got this, the conversion. Now let's try to convert again the following if else into switch. Now here the if given is if P is 10.5 then run A, but if P is 12.5 then run B, otherwise run C. So in the attempt of writing switch, we will write switch P, correct? And then case, remember case means double equal to case 10.5 because that's the value you want to compare. Then run A and then break. But listen, this is wrong because in switch statement, you can only compare integer values. Compare only int values or even short values. We call it as short int. That's also allowed. Or characters. Characters can be compared because characters, you will see later, is nothing but recognized by ASCII codes. And ASCII codes are nothing but integer values. Like ASCII code of capital A is 65 or ASCII code of small a is 97. So characters are nothing but ASCII codes. So integers or short integers or characters can be compared using switch. But you see in this example, you are comparing 10.5, which is a float. So after the word case, you can only have integer values. So such an if statement given cannot be converted into switch. So switch has a disadvantage or rather limitation we can say instead of disadvantage. That switch can be used only for comparing integer values. Okay, so no chance. You can't convert this, and you have to rely on if else only. You will have to write if else. Let's see the third example. Let's try to convert following if else into switch. Now this if else says if P is less than 10, run A. Otherwise check is P less than 20, then run B. Otherwise run C. Now in the attempt of converting this into switch, you will write switch P and then brace open, which is always compulsory, and then the word case. Now, as soon as you write case, case means double equal to, come on, correct or not? And then if you write 10 here, thinking that you are comparing P with 10, notice the if you are comparing P with 10. So you said switch P 10, but this condition that we have written becomes if P is double equal to 10, because case word means equal to. What you watch here is switch has no facility whatsoever to check for less than. Come again, switch cannot check whether one value is less than other value. Less than, greater than, less than or equal to, greater than or equal to, not equal to. There is no facility given in the switch which can be used to compare for less than or greater than or any of these relational operators. Switch can perform only equality comparison. So in case your original if had P equal to 10, fine. P equal to 20, okay, then we can convert it into switch. But if your original if has less than, greater than or equal to some relational operators other than equal to, you cannot convert it. What are the disadvantages of switch? I hope you have got this. Anyway, switch is replacement to if, but switch can be a replacement to if else only if the comparison operator used is equal to. Only then you can write switch. All right. Let's check the next example. In this example, it is asked that what is the output of the following. Very interesting. Let's see. In this, we have x equal to 1, as you see, and then switch x. So what are we checking is what is the value of x? Is it 1 we are checking? Yes, it is 1, isn't it? So case 1 becomes true because x is 1. As case 1 becomes true, printf runs, that is action is taken. As case 1 is true, the action for return for case 1 is taken, which prints 1. So 1 is printed on the screen. But big point you notice over here. Yes, really a big point. Now after this case 1, which has become true, break statement is missing here. Break is missing. Isn't it so? So what happens if break is missing? Listen very carefully. Case 1 is true. It has executed the action for case 1, but break is missing. Then blindly other cases will execute. Blindly other cases will execute. It will not check, hello, it will not check whether case 2 is true or not. Case 3 is true or not. It will not bother to check this left branch here. Which case is true now? Because case 1 has become true, it has already gone inside and executed the printf, and break is missing. So it will blindly execute remaining cases. So it will execute printf 2, so 2 will be printed. It will execute printf 3, so 3 will be printed, and it will execute printf def for default case, and it will execute def also. Remarkable, isn't it? What is the observation you do is, in one sentence, the observation is, whenever any case becomes true, whenever any case becomes true, then that case runs. And if we do not have break for that case, then next case runs without checking whether the case is true or false. The action written for the next case runs, and it goes on till the break is encountered or till the end of switch. Let's see what I mean. The next example will speak enough about this. Let's see. What is the output of the following switch? You see X is again 1 and we are checking switch X. Now you know as X is 1, case 1 will become true. Yes. So case 1 will run. As case 1 runs, 1 gets printed. But you watch, the case 1 runs, but break isn't there, isn't it? Break is not given. Then next case will also run. It will not check whether the case is true or false. It will blindly run the action written for the next case, which is printf 2. 2 will get printed. And then, good Lord, then after that break is there, you observe this break. And whenever break runs, it will pull the control out of switch. So remaining cases, case 3 and default will not run. So the output of this is 1, 2. Check it again. What would have happened if I would have given x as 2 here? Check the initialization. Now the value of x is 2. So when switch x is checked, it will first check whether case 1 is true. But you notice case 1 is false because x is 2. So no question of running printf1, isn't it? When will the action run? Only if the case is true. But case 1 written on top was false because x is 2. Then case 2 will be checked. And case 2 is true because x is 2. Yes, x is 2. So case 2 is true. So it will run printf2. 2 will get printed and then break. Nice. Break will pull the control out. So the output of this is only 2. Check it thoroughly again. What if? What if I initialize x as 3? Now how is this going to run? What is the output? Okay, I'll take a pause. What is the output? Yes, the output is 3 and def. You are correct. Let's see how x is 3. So switch x will check whether x is 1, case 1. No, false. So no question of executing printf1. As case 1 is false, it will check case 2. It is checking is x equal to 2, which is also false. So no question of executing printf2 and break, which is action written for case 2. Then it will check whether x is 3, case 3 is checked, which is true. So it will run printf3, 3 is printed, but notice break is missing for this case. So what happens whenever any case becomes true? That case runs, and if break is missing, the next case runs blindly. Next case is default case. It will run blindly and def will be printed. And anyway, after printf def, after def getting printed, the switch ends. So that's how you can see how switch works and what is significance of break. You have noticed what happens when you give break, what happens when you don't give break, isn't it? And many times the question about this switch like this, some confusing questions with break and without break have been asked in the GATE exam, which we will see in one of our later videos. Thank you very much.